Hi everyone, I am Teacher Michelle and welcome to another episode of Unang Math. In this episode, we will be solving some questions or problems in relation to our lesson about medians and centroid of a triangle. Without further ado, let's start with our first question. According to this, in the figure below, point G is the centroid of triangle ABC, and segment BC is parallel to segment FE. If segment AD is 18 centimeters, we will find the length of segment FG. So this is our triangle ABC. According to this one, point G is the centroid of this triangle. Segment BC, or this segment, is parallel to segment FE. It's also given that segment AD is 18 centimeters. So this is segment AD. It's 18 centimeters. We will find the length of segment FG, or this segment. Since point G is the centroid of this triangle, then it means from this vertex to this point, this segment BE is a median for this triangle. Okay, also from this vertex to this point, this is another median of this triangle. So this is a median and we have here another median. They meet at this point, so point G is the centroid of this triangle. We already studied that the centroid of a triangle divides the median in the ratio 2:1. So it means from this point to this point, this is in the ratio 2:1. Since this is also a median, so this is also in the ratio 2:1. Okay, if segment AD is 18 centimeters, then it means segment AG, since it's in the ratio 2, so 18 divided by 3 is 6. 6 times 2, so segment AG is 12 centimeters. Okay, what about segment DG? So it means segment DG is 6 centimeters. Okay, now, to find this segment FG, let's consider this triangle and this triangle. Okay, again, we have here segment AG. This is 12 centimeters and DG is 6 centimeters. Okay, considering these two triangles are similar figures. To prove that these are really similar figures, this angle and this angle are vertical angles, so equal in measures. Since segment FE and BC are parallel lines, then it means this angle and this angle are alternate interior angles, so equal in measures. This angle and this angle are another pair of alternate interior angles, so equal in measures. So this is AA similarity. So these two triangles are similar figures. So if similar figures, then the ratio of the length of the corresponding sides are equal or constant. Since we said that segment BE is a median for this triangle, and again, this is in the ratio 2:1. So it means this is also in the ratio 2:1. So we already got the measure of segment DG, which is 6 centimeter. And it's in the ratio 2. So it means segment FG in the ratio 1 is equal to 3 centimeters. So the length of segment FG is 3 centimeters. Okay, moving on to our second question. According to this, in isosceles triangle ABC with segment AB equals to segment AC, we will let point M be on the side of segment BC. Point G and G prime are the centroid of triangle ABM and triangle AMC, respectively. If segment G, G prime is equal to 8 centimeters, find the length of segment BC. So this is our isosceles triangle ABC. This side, or segment AB, is same length with segment AC. It's also given that point M is, or this point, this is on this side or on this segment BC. Another given is point G, or this point, and point G prime are the centroids of these triangle ABM and triangle AMC. Okay, another given is the length of segment G and G prime, which is 8 centimeters. Okay, now, how are we going to find the length of segment BC, or this segment? Okay, since it's given that point G is the centroid of triangle ABM, or this triangle, then it means from this vertex to this point, this segment AD is a median for this triangle ABM. So it means also that point B here is the midpoint of segment BM. So segment BD is just the same length with segment DM. Okay, another centroid is this point G prime. So this is the centroid of triangle AMC. So triangle AMC. So it means from this vertex to this point, this segment AE is the median, or a median for this triangle AMC. So this point E is the midpoint of segment MC. So segment ME is the same length with segment EC. Okay, now, since segment AD and segment AE are medians, and if we are going to recall the concept about centroids of a triangle, it divides the median in the ratio 2:1. So this is a median, and this is another median. It's in the ratio 2:1. So these centroids divide this median in the ratio 2:1. So this is 2:1. This is also 2:1. Okay, now, to find the measure of segment BC, let's consider this triangle and this bigger triangle. So we have triangle AGG prime and triangle ADE. These two triangles are similar figures. To prove that these are really similar figures, this angle is common angle for these two triangles. This is just the same with this one. So this is SAS similarity. So it means the ratio of the length of the corresponding sides are constant or equal. So to find the length of this segment DE, since it's already given that segment GG prime is 8 centimeters, so this GG prime corresponds to this segment DE. So the ratio would be, this is 2:3. So we have 2:3. That would be equal to this length of GG prime, which is 8, is to this length DE, or segment DE, which is, let's say, X. So we have here 24 is equal to 2x. So it means x is equal to 12. So segment DE is 12 centimeters. Since this is just, or this length is just the same with segment BD and segment EC, or combined segment BD and segment EC, then to find the length of segment BC, we just have to multiply 12 by 2. So this is now equal to 24 centimeters. So the length of segment BC is 24 centimeters. Okay, and for the last question or problem, let's also answer this one. In a parallelogram ABCD, point M and N are the midpoints of segment BC and CB, respectively. If segment PQ is equal to 6 centimeters, we will find the length of segment BD. So this is our parallelogram ABCD. Point M and N are the midpoints. So where are point M and N? These are the points M and N. And according to this question, it's the midpoints of segment BC and segment CD. It's also given that segment PQ is equal to 6 centimeters, or this segment is 6 centimeters. We are looking for the length of segment BD, or this segment. Okay, we already know that if it's a parallelogram, then we have here two pairs of opposite sides that are parallel and equal in length. It's also given here that there is a point P and point Q here, but we are unsure or we don't know yet what are these points in this figure. So to find out and also to find the length of segment BD, we are going to consider the diagonals or the property of the diagonals of a parallelogram. So from this vertex to this vertex, let's draw a straight line. So this is a diagonal of this parallelogram. And from this point or from this vertex to this point, this is another diagonal of this parallelogram. These two diagonals meet at this point. So this is the midpoint of this segment BD and segment AC. So this point, let's name this point point O. So segment AO is same length with segment OC. Segment BO is the same length with segment OD. Okay, now, we know that point M and N are midpoints of these segments. And we also know that point O is the point of intersection of these two diagonals. And this point bisects the diagonal into two equal length or two equal parts. What about point P and point Q here? Point Q here. Okay, to find what is point P and point Q, let's consider this triangle A, B, C. Okay, if we're going to take a look at triangle A, B, C, since point M is the midpoint of segment BC, and this point also is the midpoint of this segment AC, then we found out that point P here is the centroid for this triangle ABC. Take a look at this one. This is a vertex from point B to this point, midpoint of segment AC. It means this is a median for this triangle ABC. Another one is from this point or from this vertex to this midpoint of segment BC. This is another median for this triangle. So these two medians meet or intersect at this point. So point P is the centroid of triangle ABC. So the centroid of a triangle, again, it divides the median in the ratio 2:1. So it means from this point to this point, this is in the ratio 2. And from here to here, 1. So 2:1. Okay, now, we have here another triangle, ADC or triangle ACD. Let's also find out what is point Q here. Okay, since it's given that point N is the midpoint of segment CD, and again, this point O is the midpoint of this segment AC, then it means this point Q is the centroid for this triangle ACD. So from this vertex to this midpoint of segment AC, this segment DO is a median for triangle ACD. We have another here from this vertex to this midpoint of segment CD. This segment AN is another median for this triangle ACD. So median, we have here another median. They meet at this point Q. So point Q is the centroid for this triangle. So centroid divides the median in a ratio 2:1. So this is in the ratio 2:1. Okay, we already know that segment PQ is 6 centimeters. And this point O divides this segment BD into 2 equal parts. Then it means that this segment BP is the same length with segment PQ and same length also with segment DQ. So this is 6 centimeters, 6 centimeters, 6 centimeters. So 6 times 3 or 6 plus 6 plus 6. That means segment BD is now equal to 18 centimeters. So for this question, the length of segment BD is 18 centimeters.